Welcome, welcome. Hugging Casts, if this is your first time you join our show, is a live show about building AI with open models and open source. And in this new season, this is our second season, each episode is about how you can build AI with open models using the work we do with one of our partners. And so it's a little less news and it's a little more demos than last year. And our goal is that you can walk away from this having learned practical examples that you can apply to your use cases in your company. We want to continue making this show live and interactive. So after the demos, in about 30 minutes, we'll start taking your questions from the live chat. At Hugging Face, we want to build an open platform where we make it easy to use our models and libraries on whichever compute stack you want to use. And that's why we work with cloud platforms like AWS, Google Cloud, Azure, Cloudflare, with hardware platforms like Nvidia, Intel, and AMD, with on-prem platforms like Dell and IBM to build all these experiences that make it easy for you to build your own AI with open models. And this second episode will be all about our collaboration with Nvidia. It's GTC week this week after all, and we want to show you how you can accelerate your work building AI with open models. So there you have it. In this season, you can expect more demos, you can expect new Hugging Faces to come share their work, and more ways to build AI in all kinds of compute environments. And speaking of new Hugging Faces, it's my pleasure to welcome Abhishek, Rafa, and Morgan to the show. Hey guys, do you want to say hello?
Hey, hi everyone.
Hello, hello.
Hi
So
everyone.
Abhishek, you're the creator of AutoTrain. Rafa, you build train on DGX Cloud. Morgan, you're building Optimum Nvidia, amongst all other things, machine learning optimization. Thank you so much for joining, and thank you for bringing your demos. I want to give some context on all the things that we're going to show you. And so I prepared a little bit of content for this. Let me put it up on the screen right now. Okay, what is this all about? So there's this meme right now in the community about GPU rich and GPU poor. And all the everything that we're doing here, the goal is to give access to the latest GPUs and the latest acceleration capabilities of these GPUs to the community. So GPU poor don't need to be GPU poor no more. You have access on demand to the latest GPUs, and we make it easy through Hugging Face. Super exciting. Today we're unveiling a new service. We announced it yesterday at GTC. It's called Train on DGX Cloud, and I'm spilling the beans here, but the goal is to allow you to train with H100s directly without any code, without any server or setting up any cloud account, directly on the Hugging Face hub. And that's one of the main things we want to show you today. Overall, our collaboration with Nvidia has as a goal to help you accelerate your AI workloads when you're working with Hugging Face open models and open source. We want you to have faster training, faster inference. And so faster training, here comes Train on DGX Cloud. It's a new hub service. You can access it today on the Hugging Face hub. And what it allows you to do is to fine-tune LLMs, but not just, directly on the hub using H100s available on demand or L40S without having to add any code. And how it works, we'll show you in more detail, but I want to give you the high level. So if you pick a model, you will find a new option within the train menu called Nvidia DGX Cloud. And once you do that, you can select your enterprise hub organization. Train on DGX Cloud is available to enterprise hub organization, which is our way of providing security around organizations on the hub. SSO, advanced security features, advanced compute features, fine-grained access control to repositories, everything is within this enterprise hub. And so if you're a member of an enterprise hub organization, you will have access. You can select your organization in that step. Once you're in, once everything is set up, all you need to do is to set your parameters. You pick your hardware, you set your training parameters, and we'll show you how. And once you've done, once you click start training, then, well, everything happens under the hood. And under the hood, we spin everything up. You have access to the logs of what's going on. And then once the training starts, you can sit back and relax and see how it goes through a tensor board. So that's in a nutshell, train on DGX Cloud. The end result is a model, a private model that's hosted for you. You can use it anywhere you like. All right. In terms of features, we'll go more into detail, but I mentioned it's not just LLMs. For LLMs, we give you easy options to do advanced fine-tuning, right? So you can do supervised fine-tuning, you can do reinforcement learning from human feedback, like using the DPO method or using other methods. You can use train on DGX Cloud on the most popular open models out there, from Llama 2 to Mistral, Gemma, and many more. And you can also do image generation. So train on DGX Cloud is a very easy way to use Dreambooth and create adapters via LoRa for your Stable Diffusion or Stable Diffusion XL models. In terms of compute, so as I mentioned, we have H100s and L40S. The H100s are available in different sizes of an instance, depending on how fast you want your training job to complete. And you only need to pay for what you're actually using. And so it's compute by the hour. We have great prices in collaboration with Nvidia, and we actually compute your usage duration by the minute. And so to give you an example of what that means, like we tried fine-tuning Mistral 7B on a 1500 sample data set, and using the L40S, which is the cheapest option available, we're able to do so with less than $50. So it gives you, it puts into perspective sort of this overall goal to make it accessible for the GPU poor to have great ways to train their own models, to build their own AI in a way that is affordable. All right, so that's train on DGX Cloud, and we'll get into it. The second thing that we want to talk about today, that is the fruit of our collaboration with NVIDIA, is Optimum Nvidia. You may know Optimum, our toolkit for acceleration of AI workloads. Optimum Nvidia gives you the acceleration of, I lost my slide. There we go. It gives you the acceleration of the best of NVIDIA open source with TensorRT-LLM with just one line change within your code. Instead of using the vanilla transformers pipeline for inference, you're using the Optimum Nvidia accelerated pipeline for inference, and you get all the benefits. And when you're using this with the latest hardware from Nvidia, you're getting a lot of benefits. We measure two main metrics to measure the benefit. One is the time to first token, also known as first token latency. And on consumer or server sort of hardware, from the 4080 GPU to L40S and H100, we were able to get 3x shorter time to first token, which is really important because this is the sort of responsiveness of your application if you're putting a chat interface in front of your customers. And second, we wanted to measure the max throughput we were able to achieve. And again, we looked at consumer cards and server cards, 4090, L40S and H100, and at the max, we're able to get up to 28 times better throughput by leveraging all the benefits of Optimum Nvidia. So super exciting. Now I want to let the team who built all of this show you in detail how it all works. So let me take my slides off, and yeah, super excited to hand it over to you, Abhishek. Yeah, take it over. Thank you. Well, Abhishek, we don't have your sound. Yeah, there we go. There we go.
Sorry. Yeah, thank you so much, Jeff. It's been a while since I came live, so I forgot I have to unmute myself. So I think you have discussed quite an overview of everything that we are going to discuss today. If you know me from my social handles, you will always see me talking about auto train this, auto train that, and new features in auto train. But today I'm going to tell you a little bit about like the history behind it. When we started auto train, it was called Auto NLP, and at that time it was a closed source project, and um, we used to train only the transformer models for natural language processing. But later on it evolved, and we added many other different tasks like image classification and dream booth LoRa, these kind of tasks, and even tabular classification and regression tasks. And the name changed to AutoTrain, and last year we decided we just open source it. So we created another library called AutoTrain Advanced, and we open sourced under that name. So when you go to huggingface.co/autotrain, you can click on create a new project, which will take you to create a space where you can name a space and keep everything the same, and you can choose a space hardware. So I'm not going to show you this part today, where you choose a space hardware and you do the training. Obviously, keep it private, otherwise other people can also train on your space. So since today, we are talking about DGX Cloud. I'm not going to show you how you can train on spaces, but I'm going to show you how the AutoTrain framework UI looks like. So once you have created a space, you can sign in, and here you can see I'm running it on A10G, and I have a bunch of different tasks like LLM SFT, LLM DPO, text classification, token classification, sequence classification, image classification, dream booth, LoRa, and so on. Um, and we have also added like a feature where you can select between basic parameters and full parameters, because often people are scared by seeing so many different kinds of parameters and they don't know what to tune. But most of the tasks, you don't need to tune all the parameters. You only need to tune a subset of parameters. So if you go to full, you will see like there's so many parameters, but don't worry about it. Just click on basic, and then with these are the most common parameters, and mostly everyone knows about it. Once you have done that, you can select a hub dataset, or you can upload your dataset, and you can just click on train, start training button, and then you will also see the logs. So now this space is running on Hugging Face Spaces infrastructure. It's using A10G, but we want to train on DGX Cloud. And for that, Rafa has done some incredible work running uh, the backend on DGX Cloud, and he's going to show you how we can do that. And if you have any questions, please feel free to ask me.
Awesome. Great stuff. All right. I'm going to share my screen and try to continue from where Abhishek stopped.
Nice.
So by now, I think I have a good idea about what's AutoTrain. I think it's a fantastic idea, by the way, because for the first time, I think a project that I'm working on that even my mother knows how to use, because it's super easy to use. Yeah, so super exciting. But how does it work? Let's say we have Mistral with 7 billion parameters, for instance, one of the best models, open models out there, or Llama 7 billion or 70 billion. Let's say that you want to train that using NVIDIA GPUs. Where would you start? Right. So as Abhishek was showing, as also Jav was showing in the beginning, if you are part of an enterprise organization, you're going to have a new button in the drop-down for training. Once you click on that button, train on NVIDIA DGX Cloud, you're going to be redirected to this screen that I'm showing here. So you have some parameters. You can choose which of the GPU cards you want to use. If you want to go for 1, 800, 2, 4, or even 8. You're going to select the type of task. So we're going with supervised fine tuning. You could also choose DPO or other types of tasks. If you're going for diffusers, for example, you would go for LoRa and so on. For this example, let's keep it simple. So we're going to just fine tune Mistral 7B. I'm going to upload my data set, which is a subset of Alpaca with 1,000 rows. I don't need to do any mapping because the columns are already in the right format. And I'm not going to change any parameters. But the nice thing to know here is if you just want to explore, or if you're pretty sure that you don't need to play around with parameters, you can just go with the basic parameter subset. If you want to fine tune it a bit more, change more of these parameters, you can go with the full and change it through the UI. Super simple. So we're ready to start
That's really
training.
cool. And by the way, Rafa, sorry to interrupt you, but
Yep.
I did the demo session yesterday at GTC where we announced this product, and in my screenshots, I didn't have the ability to upload a data set from the hub. I think we added that just like yesterday, Abhishek.
Yeah, we added that yesterday, and we added the functionality of basic and full parameters today. So
That's super cool. So yeah, I'm discovering new features from the demo. That's super cool. Go ahead, Rafa. Sorry.
No, of course, it's a really good shot. So hot off the presses, you have two options now. So either upload it from your computer, the data set, but if you have already a data set, either private or public, you can paste the ID for this data set here, and you can also choose the train and test split. Super useful. We're gonna keep it simple, so we're gonna just upload the subset as a set. We should be good to go because we don't need to change parameters just for this example. I'm just gonna set epochs to 1, try to run it fast, and that's it. We click on train. What happened under the hood here after we click train? So the first thing is AutoTrain is going to create this project here. We're going to see later on after we start training. So this is the project where the model artifacts are going to be stored, but also the training metrics are going to be stored in real time, right? I'm just going to copy it here, but before we go and see this project, how it looks like, we want to check the progress of our training. So we have live logs from the GPU machines running on the Nvidia side. So basically the progress of downloading data, but also the progress of training, how many steps we have had so far, and so on. We're gonna leave it here for now. I just want to show quickly how this project would look like. So I'm gonna go to my profile. One interesting thing here is that since I selected my user, the model that we are training is going to be created under my account. So to have a look over it, go to my account. We can see that there is already a project there. There's still no artifacts because
actually I don't think we can see it. I think we're still in the
on the previous screen.
Window.
Yes, so I need to change my screen here. All right.
There we go.
Yeah, awesome. So we have the project already. It's created on the hub. We can see that it's a private model, which means that only myself, only I can see it. You can change the visibility if you wish, but the nice thing here is as soon as we actually start training, we're going to see some training metrics which are generated through TensorRT, and it's going to be updated on the fly. Super nice one. So right now there's not much in terms of parameters, but also depending on the logging parameters that we configure in AutoTrain, it could be that this is updated more or less frequently. So we can have a look again at our logs and see how it's going. So super fast. So finished training. Now we're pushing model artifacts to the hub, and that's pretty much it. So 3 or 4 clicks, we fine tune our LLM, and yeah, using NVIDIA GPU super fast, as you see.
Wow, that's amazing. So actually the training job that you started during the demo is already pretty much finished?
Yeah.
Wow. That's really cool.
maybe we can see the artifacts one more time.
Yeah, let's go there and have a look.
I think you need to change it.
Balu is super excited. But Balu is a special guest today. Yeah, as you can see, training is finished. So AutoTrain does that automatically for you. So you created a model card, which you can customize and change it if you want. We can have a look at the files and artifacts that it generated. So by default, it converts the model binaries to the safe tensors format, which is great. And we have these two folders here. So we have the last checkpoint. Again, this is adjustable through the parameters for AutoTrain. We also have the TensorBoard logs for our runs. So let's have a look at our training metrics. Not going to have a lot of data because it's just one epoch, but if we have many different, much more than one epoch and have training for hours or even days, this is super useful to see, okay, is my training converging? Do I need to change any of the parameters or not? And yeah, you basically keep track of all of that.
Oh, that's amazing. I'm still blown away that it just took 4 minutes to get everything with like the model card and the training metrics and just the model available. And there's even like a widget where you can test the model right in place. That's super, super cool. And there were some great questions in the chat. Viresh was asking like, so what's the cost of this training? And I didn't really time it exactly, but I think it sort of took like maybe 4 minutes, 5 minutes end to end. And did you select the L40S for this one? Or was it H100?
This one was H100.
H100. So H100 is $8.75 an hour. So here was 5 minutes. So if I divide by 20, that's about 40 cents. So it's less than half a dollar to do this job. So yeah, Tanvir would like to see your cat, Morgan. And what is that's a great question actually. What is the max size of a data set that you can use through train on DGX Cloud?
We have not evaluated max size, but I have trained over 100,000 samples and it works quite well.
Really, yeah, I think it pretty much will be, the constraint will be the GPU size that you're using, and also the batch size, of course.
Yeah.
But there's not really a limitation, like a hard limitation on this sense.
That's really cool. Then another great question from Senna. Who will have access to the training data set that is uploaded for the training?
So only you have access to the training data set. Training data set is processed and stored in your account. So in your Hugging Face account as a private repository. If you're uploading your own data set, if you're using a data set from the hub, it's not even processed. So you feel free to delete it after the training is done.
That's really cool. And from Subroto, also, if we run train again, does it build a link to the adapters and add-on? So maybe that's a question about the Dream Booth.
I'm not sure if I understand this question properly. So the model that was trained right now was an adapter model. We were using PEFT, and you can definitely just merge the adapter to the model weights later on if you want to do that. But even adapter models are fully supported in pipeline in solutions like Inference endpoints. So you can just go ahead and deploy it. You don't even have to merge the models. And if you're using transformers or PEFT library locally, you can just load the model without merging the weights.
Really cool. And from Jose, so this was supervised fine tuning on an LLM. And I think the data set that you use was called like Alpaca 1K. And so the question was like, what was this data set? Like, how big was that? Like, how large was each sequence?
So Alpaca is quite famous data set. If you search for Alpaca datasets, yeah. So this was the dataset that was used, and this dataset has a text column. So you can see like it has a prompt, below is an instruction, blah blah blah. Then you have the instruction, then you have the response, and this is how the dataset is formatted. But if you so when the dataset was uploaded, we uploaded JSON format. We could have also just used this dataset ID and the train split by selecting the column text. But if you have doubts on how the dataset should be formatted, we also have documentation for AutoTrain, in which you have all the different tasks that you can train on, and for each task you're provided with a simple example dataset. Now I have to um, I have to say this carefully. These are examples, so you don't have to format the dataset this way. You can format the dataset many different formats. So you have the Guanaco format, um, which is something like this. You have Alpaca format. You also have the No Robots format from Hugging Face H4 team. So you can also format it that way.
Really cool. And Abe was asking, so I mentioned my slides like Llama 2, Mistral, Mixtral. That was a Mistral you did a demo with. Like, are there any LLMs that this will not work with?
I think
Um,
in the beginning there's a group of LLMs that we support. So I think we're going to share the full list in the chat. But we try to select the ones that are most popular and also most performant. So, for instance, all variations of Llama 2, Falcon, Mistral, but also Mixtral. So, mixture of experts is also supported. Starcoder, FLAM-T5, and then multimodal models. So, we support Stable Diffusion and Stable Diffusion itself. If there is any other model that you would like to see and would like to be supported, yeah, please let us know.
Super cool. Thanks. No, I think what's important to remember is like for say Llama 2, it's actually an architecture, and on the hub there are probably thousands, if not tens of thousands, of fine tunes of Llama 2, and so all of these model checkpoints can be the starting point for your fine tuning. I want to make sure we cover an exciting new demo of Optimum Nvidia. Optimum Nvidia is our open source toolkit to get the full benefits of TensorRT-LLM in an easy to use package. So it's only a line code change to get the benefit if you have access to this hardware. And of course, it's an open source project. You can check it out on our GitHub. I can pop the link right here. And here we have an exciting demo, and it's sort of a prototype and a proof of concept. It's not something that you can do yourself at home, but we wanted to show you to inspire you to get the benefits using this new open source package, again, Optimum Nvidia. So happy to hand it over to you, Morgan, to show everyone what you've been cooking.
Sure. Thank you very much, Jeff. Can you hear me well? Yeah.
Perfectly.
Awesome. Quite a long time I've been doing this, so let me share my screen. Where it is, just over there. All right. So as Jeff mentioned, I just cook a very quick demo. So just a brief intro on Optimum Nvidia and TensorRT-LLM, TensorRT as a whole. So Optimum Nvidia is really like a wrapper around the technology put by Nvidia, namely TensorRT, which is the compilation and compiler engine and runtime for running fast inference on NVIDIA GPUs. And one of the limitations that was present in TensorRT is that it was mono GPU. So with TensorRT-LLM, they're opening up a bit and focusing on more like the large scale language model that we are seeing nowadays. And really, the goal of Optimum NVIDIA is that we want a game face user and especially transformer user to feel at home with this technology and being able to leverage the great performance that it offers. So that's really the trajectory that we are following. And just here to show you all the cool things that you can do and how similar it is to the transformer API, I made up this very quick demo. So as you can see, for
Can
the
you zoom in a little bit? Sorry to interrupt you.
sure,
I think
is it any better right now?
much better. Maybe one more time. There we go.
All right.
Thank
Awesome.
you.
So yeah, for the transformer user, I'm pretty sure you are already spotting a few things that you are familiar with. So we have the auto tokenizer, of course, that we will be using later on. But really, the important piece is the auto model focus element. So this is really the same API that we are able to see on transformer. And so this is a very live demo. So I hope that it will go well. We'll see in a few minutes, right? But as you can see, I will just be allocating a model that I will be taking from the hub. So here we will take Gamma 2B. Um, okay, I'm taking the 2B because it's quite fast to load, to convert, to compile, and run inference into on my 4090 I have at home. But we have much bigger LLM that you can do inference with. So here, what is going on internally and under the hood, I would say, is that we are downloading the weights from the hub, the proper safe tensor that you can have with transformer, right? And then we are putting this into the hands of TensorRT-LLM, and TensorRT-LLM will do its magic, right? So it will be looking at the graph, doing all the optimization, trying to optimize for finding new kernels and all the parameters that will make it go as fast as possible for the underlying hardware. And this is really important to notice. So the compile artifacts will be very specialized for the underlying hardware you are compiling for. So this is one of the major difference that you can have with, I would say, raw transformer nowadays. All right, let's do a quick inference. So here you can see, again, we call the generate method that you have in the transformer. The name of the parameter are the same. The API is the same. So you should feel comfortable with just one single line of code change. All right. So what is the latest generation of NVIDIA GPU? Blah blah blah, and we see that it makes a bit of sense. Well, I'm not sure about NVIDIA Pascal, but yeah, that's it. At least this is something that can sound real. Anyway, so let's move forward. One of the major improvement that we can have with TensorRT-LLM is a very easy access to upper feature, namely called the Floyd 8 engine. So this is something really at the hardware level that make it much faster to do inference. They also have stuff for training, of course, but here we'll be focusing on the inference part. And we're making this very easy to leverage as part of Optimum Nvidia just by using this single keyword argument, use FP8 equal true. And then in this case, let's see, so it will again load the model and do the magic. So just to give a bit of context of what is actually running behind the scenes. So FP8 is a quantization techniques, right? And this is not like the GPTQ, AWQ, in some extent, where you do have to do. I mean, you have to do a calibration step. So some data has to go through the model. You will be collecting statistics in order to do the quantization of those activation, and then you will be able to leverage this later on with the compile model. So this is really what is going on there. We are forwarding 5 and 12 samples through the models, collecting the activation parameter, and um, this will build the float 8 engine. So it takes a little bit of time. One thing here is that I would say is really like an easy mode where we will drive you and provide you with a data set. You don't really have to do anything special rather than just using this keyword. But if you would like to go further with more specialized data set with more samples to do the calibration and this kind of thing, then we are offering you an API to do so, and this is the bullet right after. So here again, we'll be running an inference to generate some tokens. So one of the cool thing with float 8 here is that it quantizes both the weights and the activation, but that also means that the KV cache for LLMs is also being quantized. So it's stored in float 8 too. So it basically, when you do this, you will be storing the KV cache in float 16, taking 2 bytes per data that you are storing. Then in this case, you are halving this data, the size of this data, to use only a single byte. So this is really very impressive, and it has like technical implication. As you can see, the quantized model have slightly different outputs because it's a different model in a sense, but still quite good performances. All right, I'm just cleaning some memory just to show you very quickly. And as I was mentioning, if you want to go, I would say the full way and the expert mode, as we call it internally, then you can tweak the quantization process with the kind of D-type that you would like to see for the weight and the activation, providing the tokenizer, specific data sets, and blah, 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 and many other parameters. So in this case, instead of just using use FP8, you will be providing with the full quantization config, and it should do the same. All right. So here you can see 128, and then here we go. Um, Well, I'm glad it works quite well actually. So that's pretty cool. Um, One of the cool thing I think that we would like to show you too is how you can leverage this. So as I mentioned, currently you can leverage it through Python, right? The Python API with the same API as Transformer. So this is one way of interacting with it. What we'll be working on in the coming weeks is also an asynchronous runtime that TensorRT-LLM provides so that you can do in-flight batching within Python. So this is something that will be quite cool to handle. And last but not least, we also did the kind of proof of concept of an integration with our product Inference endpoints, right? So let me share my screen. And yeah, don't try to replicate this at home. It will not work. I'm a bit lucky there because I have access to H100 on those Inference endpoints. So a big up to the Infra team for making this possible for today. But here we'll be using Gamma 7B because of course we're using H100, so we can go a little bit beefier. This is a model that I pre-quantized and I did just before this presentation. So
Could you zoom in the interface a little bit, Morgan?
of course
There
we
we go.
can.
Nice. Ooh, look at that. You you have special privileges.
Oh yeah, I can go up to 8. You see.
Morgan is not GPU pro.
All right. So again, as I was mentioning, this is really like a POC. So there is quite a significant amount of steps that still are manual, but in the future, we would like to make the experiment much mainstream for you to use. So definitely that will be slightly different, but overall the flow will be the same. So here, just to let you know, so the framework is a custom framework because we are leveraging Optimum Nvidia. And then I have, as I mentioned, the engines that are built are very hardware specific. So here I'm saying that I want to use an engine, and the revision is really H100 for the hardware and leveraging an FP8 because the model has been quantized. So the engine is quantized. And then I will use a custom data sets because I need a few more things that the default container doesn't have. And yeah, I think we should be good to go. Let me check one more time. All right, I think so. So let's create an endpoint. Hopefully, again, this is live demo, so I hope it will work. Let's refresh a bit. Shouldn't be long from the test that I've been doing this afternoon, but let's see. So
Oh,
here we are again downloading the engine that has been stored on the hub. So currently, as you saw, it's under the Optimum Nvidia organization, but in the future, we are thinking about like potentially providing some engines, Peruvian engines, publicly available. That might be some way of doing so. And the revision, so the branch on which you are pulling, is really something that is other specific to identify for your deployment. So here we go. We have the deployment that is running. So here it's leveraging the Triton Inference server from NVIDIA. Here we go. We have our endpoints that is around there. Let me try to see if I can change the screen that I'm using. Here we go. Hopefully it works. So I prepare a command there just to send to my endpoint. And I just had to fill in the new public URL that I have, and hopefully it works. Yeah, I have an answer. This is
wow.
machine learning, and yeah, it works. So yeah, it's a rather teeny workload for Watch H100, of course, but with this technology and the kind of POC that we are building there, you can leverage dynamic batching, you can leverage float 8, you can leverage KV cache with float 8, sharding TP, PP, also MOE sharding is supported. So many cool things that TensorRT-LLM offers, and that we make it available for our user through Optimum Nvidia. That's it for me.
Super cool. Thank you, Morgan. Thank you so much. And actually, that's a good segue to a great question from Jose, who's like, so does Optimum Nvidia has any benefits compared to TGI? And just for context for everyone, text generation inference, aka TGI, is Hugging Face's production solution for LLM inference, and it has a whole host of features around support for quantization, dynamic batching, and streaming, and a lot more. And it has native support for NVIDIA GPUs as well as AMD multiple backends. There are extensions for AWS Inference 2, Habana Gaudi. And so the question is, okay, so I have TGI. It's actually like the default solution when you create an inference endpoint today, if you're selecting a LLM. So in which cases would I benefit from leveraging Optimum Nvidia?
I think currently the main point for leveraging, so the kind of POC that I was showing in Optimum Nvidia is really if you are targeting like Hopper or even Ada Lovelace GPU, so L4, L4TS, this kind of thing, which support the Float 8 data type. So in this case, we're still working on the integration of such computation in TGI, and it's already there for Triton TensorRT-LLM. So if you want to move fast, then this is really the way to move forward.
And I think it ties back to what I was saying really at the beginning of the show, is that our approach, our strategy is to be an open platform. And we want to make it easy to use our models, our libraries, whichever compute environment you're running on. So we're building TGI as our production solution. But for users and customers that want to use the NVIDIA stack, like we want to make that easy, and Optimum NVIDIA is our way of making that easy. So as Morgan showed, it was like a line code change to go from vanilla transformers inference to Optimum NVIDIA accelerated pipeline. Thank you so much. We have a couple more minutes for questions. I see a lot of people have been asking, is this recorded? Yes, it's recorded. Is it going to be available after? Yes, it's going to be available after. If you come back to the same link, you will see the on demand, and then we'll publish it on YouTube as well. Okay, so I have a question from Vignesh about train on DGX Cloud. Is it possible to train using live data instead of uploading static data? I don't think so, but correct me if I'm wrong. No. Okay, that's a question about the endpoints. Are payloads persisted or cached in the endpoints? Can we set up a PL connection to it? What's a PL connection to it?
A private link, I think.
Private link connection to it and set up a zero. Okay, got it. So, so actually, these questions are not about Optimum Nvidia. These questions are about Hugging Face inference endpoints. And within Hugging Face inference endpoints, you do have the ability to use private link. What private link does is that if your data is in a specific region of, say, AWS, you can create the endpoint in the same region so that whenever requests are being sent, the data never goes on the internet. It stays in the same data center. It goes from your VPN and directly into the endpoint that is within the Hugging Face tenancy. And then to the question about payloads being persisted cached, no, we're not storing any of the inputs or the outputs whenever you're sending requests to the inference endpoint, and then it's true whether or not using private link. Okay. Great question from Joseph. Can we use Optimum Nvidia in a Hugging Face space with a Gradio SDK today?
Yeah, that's certainly possible. So I haven't tested so far, but yeah, I don't see any blockers. I just need to use a specific Docker image in order to pull up the TensorRT builds, but other than this, should work.
Awesome. Thank you so much, Morgan. Thank you, Abhishek. Thank you, Rafa. Thank you for joining the show. This was a great Hugging Cast. We will see you next month for a new episode of Hugging Cast, where we'll show you how to build great AI with open source and open models with one of our partners. Thank you so much for tuning in. You can come back to this on the same link or watch it on YouTube. Thanks, everyone.
Thanks, everyone.
Bye.
Bye.